You ever point your phone's camera at a sign and just watch the words magically change languages right there on your screen? It seriously feels like something out of a sci-fi movie, but it's happening right now with real-world AI. So in this explainer, we're going to pull back the curtain and show you exactly how your phone learned to read.
I mean, think about it. You're on vacation, you're staring at a menu you can't even begin to decipher. You just pull out your phone, point the camera, and bam, instant English. How in the world does your phone pull off that trick, basically in real time? Well, the answer lies in a really fascinating corner of AI. The tech that makes all this possible is called Scene Text Recognition, or just STR for short. That's the official name for teaching a computer how to find and actually understand text in any image you throw at it. You know, whether it's a blurry street sign or the tiny print on a cereal box. But here's the thing. To make all that convenience happen, a lot of apps have to handle your photos in a way that, well, it creates a hidden problem, one that has everything to do with your personal data and your privacy. See, a lot of these systems work by basically taking a snapshot of whatever your camera is looking at and then sending that photo up to the cloud. That's where these massive, powerful servers do all the heavy lifting of analyzing the image and figuring out what the text says. And that creates this fundamental trade-off, right? Using cloud AI is super powerful, no doubt, but it means your images, which could be private, are leaving your device. It can also be laggy if you have a bad connection, and it's totally useless if you're offline. The dream solution is on-device AI, where everything stays safe and secure on your phone. It's instant and it works absolutely anywhere. Which, of course, leads to the most logical question, right? If doing it on device is so much better for privacy and speed and everything else, why don't we just do it all right there in our pocket? And here is the heart of the problem. The most powerful AI models for reading text are like giant, energy-guzzling supercomputers. So trying to run one of those on your phone? It's like trying to cram that entire supercomputer into a tiny device that fits in your hand and runs on a little battery. They're just too big, way too complex, and they would drain your battery in no time. But what if you could redesign the AI from the ground up? What if you could make it both incredibly smart and incredibly small? Well, that is exactly what a team of researchers did with a new system they call Stride. Enter Stride, which stands for Scene Text Recognition in Device. It's kind of the hero of our story today, and it wasn't made by just taking a big AI and trying to shrink it down. No, it was built from scratch with one goal in mind, to be ridiculously efficient and lightweight, making it absolutely perfect for running directly on your phone. So, how does it work its magic? Well, Stride's incredible efficiency really comes down to two key innovations. First, it has this thing called a convolution attention module. Think of it like this. Instead of shining a giant, power-hungry floodlight on the whole image, Stride uses a super efficient laser pointer that just hones in on the parts that actually look like text. And then, to make sure it understands what it finds, it has a second trick, an orientation classifier that can instantly figure out if text is written sideways, up and down, whatever. And the best part? The researchers engineered all of this stuff while, and I'm quoting the paper here, adding very minimal computational cost. In other words, your phone gets all these new superpowers without taking a major hit to its speed or its battery life. It's brilliant. Okay, so the theory sounds amazing. It's small, it's smart, but how does Stride actually stack up when you put it to the test against all the other systems out there? First, let's just talk about its size. The whole Stride model has only 0.88 million parameters. Now, you can think of parameters as kind of like the individual neurons in an AI's brain. For comparison, some of the big models have billions of them. This tiny number means Stride is small enough to just live comfortably right on your phone. Next up, speed. It takes Stride just 2.44 milliseconds to recognize a word. To give you some perspective, a single blink of your eye takes somewhere between 100 and 400 milliseconds. So yeah, this thing is, quite literally, faster than you can blink. But are you giving up quality for all that speed? Not a chance. On the standard industry tests, Stride hit 88.4% word accuracy, which proves it's not just small and fast, it's also really, really good at its job. And when you finally put STRI'd head-to-head with other systems,
the results are an absolute game changer. It just blows past the other on-device models in speed and efficiency, and its accuracy is right up there with the much bigger, heavier, cloud-based commercial engines. So let's zoom out. We've gone through the tech, we've looked at the numbers, the results. What does a breakthrough like this actually mean for you and for that phone you carry around every day?
Well, it means three huge things. First, you get much better privacy because your photos never have to be sent to some random server. Second, your apps feel faster and more responsive because there's zero internet lag. And third, it just works all the time, even if you're on a plane or out hiking in the middle of nowhere with no signal.
And that's really what brilliant engineering is all about today. It's not always about making things bigger and more powerful. It's about making them smarter, more efficient, and way more respectful of our privacy, packing these incredible abilities into the devices we already use every single day. And all of this leaves us with one final, pretty exciting thought. Text recognition, that's just the beginning. As tech like Stride gets more and more common, you just have to wonder, what other AI superpowers, things that used to need a whole data center, are going to fit right inside our pockets next?